You know how high-level science can sometimes feel, well, kind of locked away, right? Hidden behind the doors of super expensive labs, totally out of reach. Well, that whole idea is changing, and it's changing fast. Today, we're going to dive into this amazing story about how everyday people are building their own complex scientific tools, sparking a movement that literally puts the power of discovery right in your hands.
So it all starts with this, a triumphant cry from a user on Reddit. Just imagine it, right? You're up against a deadline for a university project, the pressure is totally on, and then bam, you finally crack it. You pull off something incredible. This one simple, totally relieved shout, well, that's where our whole story kicks off today.
And really, that leads us to the big question here, doesn't it? Can you really build a complex piece of lab equipment in your own home? I mean, something as sophisticated as a gas chromatograph, a device that can literally pull apart a chemical mixture and tell you what's inside. Is that even possible with stuff you can just buy? Okay, let's find out.
All right, first up, let's talk about the person who started this whole thing for us, Reddit user Icy Insurance 2817. This is the person who did exactly that. They basically decided, you know what, I'm going to build my own scientific instrument from scratch. And in doing so, they proved that with a little bit of creativity, you really can build your own lab.
Okay, so check out this shopping list. This is where it gets really cool. The brain of the whole operation, a simple Arduino Uno. The detector, just a standard gas sensor you can get online for like a few bucks. And the column, the really critical part, it's literally a rubber hose stuffed with silica gel. It's amazing. It shows you that you don't always need a $1 million budget to tackle complex science.
So you're probably wondering, how did this all fit together? Well, the process was actually pretty straightforward. First things first, they hooked up the Arduino to the gas sensor, just to make sure they could get a signal. Step 2, they made the column by packing that rubber hose super tight with the silica gel. And then finally, it was assembly time. They connected all the pieces, using a little T-fitting so they could pump air through it and inject the sample with a syringe. I mean, it's just a brilliant piece of DIY engineering.
And here's the kicker. It worked. It actually worked. They injected a simple mix of ethanol and CO2, and this little homemade contraption produced a real, measurable signal. Now, was it perfect? No, of course not. But that one decent peak, as they called it, that was everything. It was a massive win. It proved the whole concept was solid.
Okay, that is just an incredible success story. But to really get why this is so cool, we kind of need to zoom out a bit and understand what the pros are doing. So let's dig into the science behind this thing called gas chromatography. So in a professional lab, gas chromatography, or GC for short, is a super powerful tool. Think of it like a racetrack for molecules. You have a stream of gas and it carries your sample through this long tube. Inside the tube is a special material. Now, some molecules in your sample are like little race cars. They just zip right through. Others are a bit stickier and they move way slower. And because they all move at different speeds, they come out the other end one by one, perfectly separated. Now, the real heart of this whole machine is the column. Remember, our DIY hero used a packed rubber hose. In the professional world, things are a lot more advanced. You've got two main kinds. There are the old-school packed columns, which are kind of like that rubber hose. Robust, can handle a lot. But the modern standard? That's the capillary column. It's this incredibly thin, hollow tube, almost like a human hair, that's coated on the inside. And the separation you get from these is just on another level. And this is where you really see the difference. For these professional columns, every single detail matters. The length, a longer column gives you better separation. The diameter, thinner, is more efficient. Even the thickness of that tiny coating on the inside is all meticulously engineered for a specific job. It's truly a world away from a rubber hose packed with silica gel, right? So this passion, this drive to build something, to understand it, it turns out it's not just one person on Reddit. That exact same spirit is what powers a whole community, an entire movement dedicated to hands-on learning.
So I want to introduce you to a group called ATIS. It's a German nonprofit, and their whole mission is to take science and tech out of the textbook and make it real, make it exciting for students. And how do they do that? By getting kids to build the scientific tools themselves.
And we're not talking about some tiny little club here. ATS has about 650 members all across Germany and even beyond. And it's this amazing mix of people. You've got teachers, engineers, technicians, and hobbyists, all of them volunteering their time and their know-how.
Their core philosophy is something they call Mint Instrumentelle Analytic,
Now, MINT is basically the German version of STEM. The idea behind it is so simple, but it's also incredibly powerful. They believe that the absolute best way to understand how some complicated piece of scientific equipment works is to build a simpler version of it with your own two hands. It takes these abstract ideas and makes them totally concrete.
So, what does that actually look like in the real world? Well, ATS creates these incredible kits that bring this whole hands-on science idea to life, right in the classroom. Let's check out a few of them. First up, this is their DIY spectrometer. It's a kit that lets students build a device that can actually split light into a rainbow of colors, so they can analyze the light coming from pretty much anything, an LED, a fluorescent bulb, even the flame from a chemistry experiment. Super cool.
And they don't shy away from the really complex stuff either. Check this out. It's a radiation monitor kit. Now don't worry, it's totally safe. It's actually sensitive enough to pick up the tiny, completely harmless amounts of natural radiation that come from everyday things, like potassium salt. It just totally demystifies a topic that can sound kind of scary and makes it something you can actually explore.
I love this one. It's called the Wellenschnüffler, which translates to wave sniffer. What a great name, right? It's this awesome little gadget that takes the invisible world of electromagnetic fields, all the stuff coming from our phones, our Wi-Fi, everything, and makes it audible. You can literally hear it. It makes this invisible world around us totally tangible.
But of course, these incredible kits don't just appear out of nowhere. Behind every single one of them is a super passionate and dedicated community of people, makers, teachers, and total science nuts.
And you can really see that community come to life at big events. AITS is always at major tech fairs and expos, like Ham Radio and Ideen Expo. They're there on the ground, running workshops, showing off what the students have built, and just sharing their passion for this stuff with thousands of people.
And the people who power this whole thing, it's such a great mix. You've got the teachers who are actually bringing these projects into their classrooms. You've got engineers who volunteer their professional skills. And there's this really strong backbone of amateur radio operators, the Funkamateur in German, who have so much technical know-how. And then, of course, the students. They're the ones who take these kits and do amazing things with them at science fairs and competitions.
So, look at where we've ended up. We started with one person, one triumphant post on Reddit, and we followed that spark all the way to a nationwide movement of builders and learners. It's just a powerful reminder, you know, that one person's passion, when you share it, can really inspire a whole community.
And that really just leaves one final thought for you. If you had the tools, the support, the community, what would you build? What piece of science would you want to get your hands on and really truly understand?